Okay, so here's another problem. It's an easier problem algebraically, where our goal is to find the wavelength of the sound or the frequency of the sound. Okay, what you've been told is that you have once again have a system of two speakers separated by 4 meters, and there's a screen that is placed 8 meters from the two speakers, and what is observed is that at a point P, which is 0.5 meters from this central line, the line that, the symmetric line, you hear your first minimum. Okay, and with this information we will find the frequency and the wavelength of the sound. Okay, so once again we will use our geometry, and let's just call the speakers S1 and S2, and we will know that the path difference between the two has to be equal to half lambda. So what we'll know is that S2P minus S1P is equal to half of lambda. Okay, so if we know S1P and S2P, we can figure out what lambda is. Now finding S1P and S2P is very straightforward from the geometry of this thing. Once again we'll use Pythagoras theorem, and what we'll do, we'll draw a line from point P parallel to this central symmetric line, and when we draw this line, we know that this distance here is going to be equal to 2.5, and this other distance here is going to be 1.5. So we know the vertical distance, we know the horizontal distance is 8, so we can apply Pythagoras theorem. So we know S2P is square root of 8 square plus 2.5 square, and the other one is equal to square root of 8 square plus 1.5 square, and all this is equal to half of lambda over 2. Okay, so once you calculate the two lengths, you can find lambda easily, and what you end up getting for lambda is going to be, okay, so you get lambda over 2 is equal to 8.38 minus 8.14, and the difference is equal to 4.24, and so lambda happens to be equal to 0.48 meters. So this gives you lambda. Okay, now you can find the frequency by doing simply the speed of the sound divided by lambda, which is let's assume the speed to be 331 divided by 0.48, and this gives you the frequency of the sound, which is going to be approximately that's fine, approximately 690 hertz. Okay, so make sure that you know how to apply problems of this sort. It's a simple problem, straightforward to take care of. All right, perfect.